Sir, you are muted, sir.
So in this class, we are going to start the topic of function. So C programming language is basically the structure of the C programming language is based on this function. So whatever we have so far seen is that you have to write a main, and this main is basically construct a function. We call the main function. Okay? And then we will try to understand that how this function will be applicable in the C programming language. So mostly whenever we talk about a programming language or the paradigm of programming language, then there is a specific type of paradigm which is called the modular programming language. So modular programming language allows the user or the programmer to divide the problem into subproblems, and then you can solve the subproblems independently, and the result can be integrated to form the output of the large problem. A simple example is that if you want to compute, say, if you want to compute the sum of square numbers, like say, let me restate. Say, if I want to compute a function or a series of, say, n, which is 1 plus, say, 1 square plus 2 square, say up to n square. So this problem, we can view the problem, or we can interpret the problem by a addition operation or some number of addition operation, and then there is a square operation. Clear? So let we understand that we don't have a square operator in my hand. So like C programming language does not provide you a square operation. So what we can do, I can write a function, or I can write a small program, say for module, and I input x, and this module will give me the x square. Okay? And then I can fit these things in my larger solution, like addition, and we can get this x square by iterating this addition. Like I first call this function, I first call this function with the argument of 1, I'll get a 1 square. Then I can again call this function with the argument of 2, I'll get 2 square. Then I call this module with the argument of 3, then I'll get this 3 square. Okay. So when I'm writing this main, I assume that there is a black box. So there exists a black box, and this black box will provide me the square terms. If I give him x, this black box will give me the x square. Okay? So because this x square terms, this x square operation is not available, so I have to abstract this operation in a small black box. How this black box will be designed, that we'll discuss later. So if we assume that, okay, I have these facilities, that the writing of main is little bit easy. So I can write, say, integer I equals to, say, 1, then integer, say, k, which can be looped in this way, say, which can be looped in this way, say, for k equals to 1 to n, and then I can have I equals to I plus this black box k. I supply k, and I am getting the k square as the summation. Okay, understand? So instead of having if we have this operator, if we have the operator of x square, I can easily apply say k square, and I can do these things. As this operation is not available, so I am using a black box type of scenario where I will pass the argument k and it will return me the k square. Understand? So doing this type of operation is basically, we are calling that I divide my problem into small sub problems, and after solving the sub problems and integrating the result, we'll get the final outcome of the problem. Okay. So what is the utility of these things? The utility is that when I am writing the main function, I basically do not consider that how I will solve the sub-problems. When I am solving the sub-problems, I do not consider that how we'll integrate the sub-problems. The integration of the sub-problems is the part of the main. The solution of the sub-problems is the part of that black box. And then this black box can be reused. Means the thing is that once I have to write this operation, means when I have to develop these things, that the sub problems, then that becomes an abstract of the part, and we can use this abstract in many times whenever it requires in my main problem, and making a problem easier and manageable. So it is also means efficient to write a program into sub problems, such that whenever the program is debugged by somebody else, he will easily understand and he can easily manage the whole problem. A simple example which will make sense is that if you want to find the sum of primes between 100 to 10,000, 100 to 1,000, then what is the problem that we are facing here? So the problem now we are in a problem where I have to find the sum of primes between 100 and 1,000. That means I am looking for this is a prime number, then 103 is a prime number, then maybe 107 is primes, and in this way, so I have to go up to some p, and that is my result. Okay, understand? So the problem is that how I will understand that this is a prime, because I don't have any operator which will return me a number is a prime. So C will not provide any operator. C is not providing any operator which returns that number is prime, or which will give me a particular prime. Okay. So I have to check. I have to feed a number I in a module, and it will return me, say yes, it is a prime, or no, it is not a prime. Okay. So I basically looking for a check is prime. Okay. So this check is basically checks that whether a particular input is a prime number or not. So this is that we already have done. We have write, or we have developed programs to check whether a number is a prime or not. A simple program for this is main. Say if so in say number n. So if n is equals to 2, I return prime. So it is prime. I'm writing in a clear way. Main, say I read x. So if x is equals to 2, we simply return prime. Or I have to loop int 1 for I equals to loop for 2 I less than say n x minus 1 I plus plus. If n is divisible by I, so return prime composite, or this is prime. Okay, so this is a simple check, or this is the simple black box which checks whether this X is a prime or not. What we are doing, we first looking for the value of 2. If X is 2, then straightforward we return this is a prime number. Otherwise, we are trying to divide all the numbers. This is X. So all the numbers which are less than X, we try to divide it by X. And if the result is divisible, then we say the number is composite. Otherwise, the number is a prime number. Okay, understand? Do you get this point? So this is the main that we have already designed to check whether a number is a prime or not. Okay. Okay. So now what we have to do, we have to, instead of writing a main, I am basically writing a black box type of scenario as a function. So the function will return something, and the declaration or the name of the function is prime, and it takes an argument integer, say X. Okay, so that means I have a black box where I can put some input, and this black box also returns some things in the output. Okay, so there is a opening where I can put some input to the black box, and there is an opening where I can take the output from the black box. Okay, so that says that this is the return type. So this is basically called the return type. Okay, so a return type is an integer. So what we are taking from the black box is a type of integer, and this is the argument. The argument says that what we are putting into this black box is an integer type data. Okay, understand? So the declaration is prime is having a opening as an argument, having one opening as the output. Okay, and now whatever we have done in the main, I can just simulate these things in the is prime. Okay, so it would be if X is equals to 2. So what we can do, I just return a 1. Return 1. That means, so it means is prime X will return 1 if X is prime, and 0 if X composite. That is, this is the abstraction of my is prime. The is prime will return a 1, means true if the number is itself a prime. Otherwise, false, the number is a composite. Clear? This declaration I am designing the function. So it says that if X is 2, then it returns a 1. That means X is a prime number. Otherwise, we look for a case in I, say I equals to 2, I less than, say, X minus 1, or equals to X minus 1, I plus plus, and I check if X modulo of I is equals to 0, then again I return 0 because this is a composite. Otherwise, this for loop terminates and we return 1. So this is my black box. The black box works in this way. Say is prime. So I put a input of X, then I take X equals to, if it is true, then return 1. That means X is a prime number. Okay, so it returns at this point with a 1. Otherwise, I have a for loop that will iterates and checks whether X divides by I is equals to 0. Then it returns 0. So at this point it returns 0. That means the number is composite. Otherwise it keeps on checking for I equals to 1, I equals to 2, I equals to 3, I equals to 4, 5, etc., etc. And finally, none of this case happens. We return a prime. Return 1. That means it is a prime. So this is composite. This is prime. Understand? Clear? Is that clear?
Yes, sir.
Okay.
Yes, sir.
So this black box is available too. Now this type of scenario is available to is prime. So where the integer type is the input type, then 0, 1 as integer type. This is the output. Okay. So now if we look into this program, into this solution, okay. So this is basically the declaration of the prime. This is basically the function of the prime. So I have a is prime n. We missed the part. So here it can, you have to write if n is equals to 2, return 1, something. Okay. Otherwise we check and return 0, something like this. Okay. So now this function will not work independently. So I cannot, this function will not execute unless we have not called this function. We have a call, means we have to give some input to the function and I have to take some output from the function, like simple operator. So operators cannot execute independently unless you have to code this operator in your function. Understand? So the execution of any C program basically starts with a main. So the execution of a C program never starts with a arbitrary function. So this is the declaration of a function, and this function cannot be executed arbitrarily. So the execution of the function always starts with the main. So what we have to do with the main? In the main, I have to add those numbers for which the number is a prime number. So I start by declaring a I, which will look for 100 to 1000, and I have a sum which will accumulate the addition of the primes. Okay? And then I loop this function for 100 to 1000. What we are doing, we have a condition. The condition is basically if prime I is true, means we are basically in the main, what we are doing, main, we are basically checking is prime I, whether it is true or not, true or false. Okay. So there is a if block, and this if block checks whether this condition is true. If this function returns a 1, that means the I is a prime number. If this function returns a 0, that means I is a composite number. So if it is true, it implies I is prime. If it is false, it implies I is composite. Okay. So this if condition is basically determining that whether the number is a prime or a composite. Okay. And then if the if block is true, then we are basically performing the basically sum plus equals to I. Clear? Understand? Get it? This is basically what
Yes, sir.
the function does. So here we are invoking. So we call these things as invoking of the function. We are calling the function. When we are calling the function, we must provide the argument because the function needs an argument for the computation. So it needs argument for the computation. It returns some value. The value is either a 0 or 1. Depending on the 0, the sum function will never execute. Depending on 1, the sum function or the sum operation executes. And when the sum operation executes, it accumulates the prime numbers. Understand? Clear? Okay.
Yes, sir.
Yes, sir.
So the main objective is that there are some operations. Instead of writing an is prime, I can write the whole code in this folder. Understand? So what is the difficulty of doing this? Difficulty of doing this thing is that means is prime is, if this function is again reused. If I want to use this function in my future part, then I have to again write the same sort of code, and my main program will be a little bit coupled. I'll show you another example where we have to reuse the function. Okay. The first, I basically making an abstraction of a particular segment of code, symbolic name. So this is basically the symbolic name, is prime. So is prime is basically replacing a particular set of code or executing a particular set of code with some inputs, and it returns some outputs. Okay. And that encapsulates, or that basically making easier for the programmer. So who reads this main, it is very easy to understand that, okay, there may be something, I don't know how it is performing, but there is something happening such that I is determined as or a composite. The main who is reading the main, he is not going to the details that how it is observed or how it is determined. Whereas who is reading this is prime or writing this is prime, he is not considering that how the main program will use the is prime. Understand? So that complexity is now divided into two independent ways. Okay. So now we check how this program is executed. If we look into this execution of the main, the execution of the main starts with a value of I equals to 100. Then it calls the is prime. Yeah. So is prime returns a 0. Then it does not execute the sum. Then for loop goes to the next I, and it increments the I by 101. Then it calls the is prime. Now is prime returns a 1, and when it returns a 1, this if condition is true, so sum is now added with the I. So now sum is become 101 plus sum, means so initially sum is 0, so it becomes 101. Then again I is incremented by 2. I is incremented by 1. Again is prime returns a 0, so it does not increment the sum. And at the fourth iteration, I becomes 103. Now is prime is called, it returns a 1. So again sum is added with the 103. Okay, and it keeps on doing this. Okay, understand? Is that clear?
Yes, sir.
Okay.
Yes, sir.
So, this example basically shows how I have to write a function and how I have to use this function in my main. So function cannot be executed independently. The abstraction of a function or the function has to be invoked by main, or a function can also invoke another function, but at the same time the execution must start with a main. Okay. Okay. So now the structure, the skeleton of a function, means how the function, what are the properties of the function, that we are going to discuss. Every function is basically having a prototype. This prototype means, the prototype is basically the characteristics of a function, means what are the arguments to the function, what is the output of the function, that we call the prototype. So by default, a function can take any number of arguments. So there is a function, and this function, so if there is a function fun, then C does not have any restriction that how many arguments you have to, how many upper limit of this argument. It can take any number of arguments. So in this case, I am designing the arguments. How many? Say there are 4 arguments. So argument 1, 2, 3, and 4. Okay. So function may take any number of arguments, but C has the restriction. It says that function only returns one return. So only one return value. Okay. So the declaration of this function is basically the return value, return type, then function name, then argument type, argument 1 type, then argument 2 type, and in this way there are maybe multiple number of arguments. So my is prime, it takes one argument and it returns one output. Okay? And the type is integer. This type is integer. Okay. Understand? So what the prototype says? The prototype basically says that what is the name of the function and how many arguments it is taking, what is the type of these arguments, and what is the return type of the function. Okay. The definition of the function comes later. The definition says that what is the execution of the function, means what the function performs with the arguments, or what is the internal computation of the function, that calls the definition of the function. Okay. Okay. Then C allows you, we'll discuss this thing. Point number C, when we take an example, we'll check these things. The first 2 points are important. What is the prototype? Prototype is basically saying that as an abstraction, how the function looks like, how many arguments it takes, what is the type of the arguments, and what it returns. The declaration says that, or definition says that, how the function operates. Okay. Okay. Then function parameters. The function parameters are basically called the inputs argument, and function return time is basically called the output argument. Okay. So the parameters, there may be any number of parameters, and the type may be also a null, it is called a void. Yeah. So the thing is something like this. You can write a function with a void argument, means it does not take any argument, and it can also be void. So it does not return anything. So it looks like a function. I am calling a function. It does not take any input parameter, and it does not return anything, but it does some operations here. Yeah. Basically, when we want to display something, say I want to clear my screen, or I want to display a particular pattern on the screen, then we don't need any argument, and we don't return anything. Yeah. Say a simple function is that void. Say display print. Say I am writing some star. Say something like this, and a new line, and it's. So this function is not taking any argument, because it does not have any operation on the arguments, and this function does not return anything. So what it does, it just whenever you have called this function, it only prints a line which looks something like this. Okay? Say again, if you call this function somewhere else, then again it will print a line something like this. Okay. So a function arguments may also be void. The function return types may also be void. Okay. Okay. Only you have to keep in mind that. Only you have to keep in mind that you cannot return more than one element. If you have to return, then you can return only a single type of elements as a function return. But you can take any number of arguments, even a void, as a function input. Okay. So these are the standard declaration of the function. So we are mostly very much familiar with the declaration int main. So what it says that the main function does not take any argument, so it can start its operation without any inputs. Okay? And when it terminates, the main always returns an integer types of data. So this is also a valid declaration for the main. So in this case, it does not take any argument. So the input argument is a void. So and the output argument is also a void. So it does not return anything. So this is a function which takes two integers as an argument, a and b. So a is the first argument, b is the second argument, and it also returns a floating type data as the result. Similarly, this function also takes a pointer types of integers and returns some pointer. So the simple thing is that the arguments may be any type of data which is available in your C programming language. It may be character, pointer, integer, short, float, and any part. Your return types may be also any type of data type which is available in your C programming environment. Okay. The definition of prototype of main is this is basically the default type of main declaration. So in most of the cases we are using the prototype of main as a main void returns integer. Okay. Okay, so there are some standard library functions. So what is the library functions, or what is the utility of this function? The thing is something like this. Say there are some most of the times we are using some functions which basically comes with the compiler. So when the compiler is developed, they also develops a set of functions which will help the programmer to write the program. So the first is called the library. So stdioh is basically a header file. If you include this header file in your program, then you can use all the function definitions which are available in this stdioh header file. Okay? And the most common functions that we are using is printf. So printf is a function which takes a string as a first argument and the arguments as the second, third, or fourth argument. Okay? So if I write a printf function, if I invoke the printf function, say printf, say this is my output, x is equals to percentage of d, then this is a sum. So what is the meaning of these things? The meaning is that I am calling a function. This is the invocation or call of function. Here. Then this is the argument. The argument is basically a string. So argument 1. So this is an argument 2. Okay. And it may have more arguments. If we specify multiple specifiers, say d, then it may contain a I, which is this is the third. Then this becomes argument 2 in this one. Okay. So this function I have not written I have not developed this function in my code. So this function is already available in the C programming environment. I am just reusing the function in my program. So every time when we are invoking the printf function, means I want to display something on my monitor, I am reusing the printf functions. Okay. So this gives me the facilities that we need not to rewrite the function code in every time. I just invoke the function, and then the compiler will replace this function by the code, and it is okay for the compiler, also for me. Understand? Get it? So there are different types of functions which are available in different libraries. So this is called the IO library, is standard IO library. So in this library, we will get printf, scanf, then getS, putS, or get character, etc. All these things are available. Similarly, math.h, which will give you some functionalities of the math operations, like you can use the square root, you can use the power. So square root is basically takes an argument as a double, and it computes the square root of this input and returns a double type of data. Power function takes a double as a base, exponent as a base, double, and then it computes the exponentiation of the power. Okay. Similarly, string library functions also have some standard definition, which is string length, then string copy. It works in that definition. Then stdlD, it also have some function like ASCII to integer. So this is a function. If you put a ASCII code, put constant returns the equivalent integer of the input string. So if you give you a string, then it will returns me the equivalent integer of this point. So this is called the ASCII to integer. So which converts the ASCII code into an integer part. Okay, and then exit equals etc. etc. Oh, gotcha. Now we'll take an example where we have to reuse the function. So what we have studied is basically how can I write a function, and what is the prototype of a function, and how the function is called by the main, or they are basically communicating between the main and the function call. So let us take another example where we have to where we'll see that how can we reuse the function. So the problem is here to find the sum of the primes between 100 to 1000, whose sum is also, or sum of the digit is also prime. So it says that we have to accumulate the primes between 100 to 1000. At the same time, the sum of the digits are also prime. Okay, or we can make these things from 2 to say 25. Okay, that means I try to do this thing by hand. So the first 2 is a prime number. So then is digit is only 2. So this is also prime. Then 3, then 5, then 7, then 11. So 11 is a prime number. So if I add the digit of this number, it becomes 1 plus 1 is 2, and 2 is prime. So I can include 11 here. Then I try to go for 13. So 13. So 3 plus 1 is 4. So this is not a prime. So I discard 13. Then I go for 13, 14, 15, 16, 17. So 17 means 7 plus 1 is 8. This is not a prime, so I discard 17. Then 19. So 19, 9 plus 1 is 10. This is not a prime, so I discard 19. Then 21, 23. So 3 plus 2 is 5. So this is a prime, so I include 23. So this is up to the 25. So my summation is basically 2, 3, 5, 7, 11, and 23. Okay. So what we have to do in this problem? So the first thing is that, say, I have to first determine is prime of I. Okay. So if it is true, so if this thing is true, then I have to find the sum of digit, which is basically again a function, say digit sum or sum digit, or I make these things different, which is sum is a function digit I, something like this. Yeah. So if I is a prime number, say I is 11, then I compute digit sum of 11, it becomes a 2. Then I again call is prime of digit sum. Now if this is true, I add sum equals to I. Yeah. If this is false, I just return for the next iteration. If it is false, I just return for the next iteration. Okay. Is that clear? Little bit. So I give a number of I give a number I, then I invoke is prime. If is prime is true, then what we have to do? We have to compute the sum of the digits. The sum of the digits is accumulated in digit sum. Again, I have to check whether this digit sum is a prime number or not. So again, I invoke is prime with the digit sum. Then if it is true, finally we will accumulate I with the sum. Otherwise, in neither case we'll return. In either case, we'll return to the next iteration of I. Okay. Understand?
Yes, sir.
Okay. So here what we are doing, we are basically reusing the function. So once I have designed the is prime, so I have already designed this is prime. So then I am using this function as a reuse of this part. Okay. Understand? So if we do these things in a linear way, means instead of using the function, if we want to do these things by writing code, then I have to write the same code in multiple times. So I have to write the same code for is prime here, then there will be a code for is digit, then there will be a code for is prime, and your program will be little bit cumbersome. Your program will be lengthy, and it is difficult to get sense. There will be many variables appear in this program, and that becomes the program little bit nasty. Okay, so what we do, we basically exclude this code, and we just replace the code using some symbolic part. So the symbolic part is the is prime, the symbolic part is the is some digit, etc. Okay. Okay. So I can show you the implementation. So the implementation looks something like this. This is the main, and we have two declarations. So this is the prototype. The prototype declaration says that there is a function which name is prime. It takes a argument as an integer, and it returns an argument as an integer. Some digit, again it takes an argument as an integer, returns an argument as an integer. So this is the main. So what the main does? The main will accumulate the sum in a variable. It computes the digit sum in this variable, and then there is an iteration. The iteration runs for 2 to 25, and then for the iteration of 2, it invokes the is prime. So as this is true, if the I is a prime number, then it computes the digit sum. Okay? Then again it invokes the is prime. And if both of these conditions is true, if this is true, and followed by this if is true, then we basically accumulate the prime into the sum. Otherwise, we are returning to the next iteration. Okay? So writing or interpreting this code is easy for me, because I can understand that is prime returns a true if the I is prime returns a 0 if the I is composite. Digit sum returns me the sum of the digit. I don't know how it does, but it returns the sum of the digit. Okay. Now we come to the declaration of the function.
Sir, one question.
Yes. Yes.
Sir, am I audible?
Yes.
Sir, is prototype declaration compulsory in C? Sir, is prototype?
I'll discuss these things. Okay, just after this explanation, I'll discuss. Then what we do? We basically write this is prime. So I forgot what I only looking into the how I can determine a prime number. So I am writing a code for determining a prime number. At the same time, when I am writing the is digit, some digit, I forgot everything. I only write a code by taking an argument n and compute the sum of the digits. Yeah, understand? So there are many things that we observe in this part, and we'll discuss these things gradually. So the first thing is that the prototype. The prototype is basically, it says, it is basically what it is saying. Say in a program, we are having different types of variables. So one variables, we understand that it is some type, like integer, a, float, a. So all these variables we have already encountered. And there is another variable which is called the function name. Yes. So the function name, you can name this function in any way. Say I have written these things is prime. You can name this function indifferently. Is the number is prime is also a valid name. But the thing is that how the programmer or how the compiler will understand that okay, this is basically a function name. This is not an integer, or what is the characteristics of this function name, and that things is basically determined by the prototype. So if we have a prototype of a function, then it basically implies a symbol and its characteristics. That characteristic says that it is a function. It will have some arguments. It will have some return type. Okay, understand? Now the question is that why this prototype is important. The prototype is important in the sense that you can define the function or you can declare the function in anywhere of your program. Yeah, but if you declare the functions or if you have the definition of the function after the main, so this is your main, and you are declaring or you are defining the function after the main, then you have to declare the prototype at the beginning of this main, so that when the compiler compiles, it understands that okay, these are the symbols. These are the symbols which are already declared as function. So when it gets into the main, it will identify that this is a symbol which is declared as a main. It is a function. It is not a variable. Okay. Prior to the main. So if I move this whole code, if I move the whole code before the main, then we need not to declare this prototype. We need not to declare the prototype here. In this case, the declaration of the prototype and the definition of the function is available prior to the main. So when main encounter this symbol, then it understands that okay, it is already defined as a function, and the declaration of the function is also available. Okay, so the main point is that why the prototype is important. The prototype is important in the sense that sometimes I am writing the main, I don't know how the function or who will develop in the function. So I only have the definition of this prototype. The prototype only gives me that okay, there are some things which will be available for me, and it will taking some arguments and it will return some things. Okay? So considering the scenario that I have not have the definition of this digit, sum digit. So somebody else will be implementing this sum digit. So what we have to do, we just include the sum digit as a prototype, such that main can identify that okay, this is a function. This symbol is basically representing a function, and it has some return type. It has some arguments, and the main program will compile accordingly. Understand? So otherwise, if you declare all the definition following by the main, then the prototype is necessary. Otherwise, the prototype is not necessary. Okay. Get it?
Sir, but one this error I like encountered while writing the program. I declared the function before the main, but the error comes and it says that implicit function declaration is not allowed in C programming.
Implicit. I'm not getting. We'll check that part. Then I can make a comment.
Okay,
Okay.
sir.
And then you can also see that I have reused the symbols many times. Like say I have reused the n in the function declaration of is prime. I can use the same symbol n in the function declaration of the is prime. I have used the I in differently. In different way, I am using these same variables I. Yeah. So in our next class, we try to understand that what is these variables, how these variables will be using, why they are not making a confusion. So once the I take the value of 2, then say in this main I is taking the value of 2, then if it goes into this is prime, again I will take the value from 2, 3, 4, 5, 6, etc. Then does the value of I in the is prime collides with the value of I in the main? So these are the issues that we'll discuss later on. Understand? Similarly,
So we initialize I equal to 0.
Yes.
If we do not want any other value of I, we can initialize in each function.
No, the thing is not like that. I am using the sum. Say I am using the sum is equals to 0 here. Understand? So in my execution, sum takes some value. Say it takes some value of 50 in my execution. Sum in some point it takes the value of equals to 50. But when I enter into the digit sum, there is a similar variable. In the digit sum, you'll find that there is a similar variable of sum. Understand? So here it is already having the value of 50. Now, does this sum will increment with 50 plus the result, or it will having a different storage, different allocation, different interpretation? That is the main point. Understand? Clear? Do you get this point?
So I think it starts from 50, right? That time.
Then my program will not execute. Means if the sum here, if the value of 50 with the sum is applicable in the digit sum, then I cannot get the sum of the digits. The sum of the digits should start with a 0. Understand? Yeah. So here I initialize these things with a 0. Then does it modify the sum here? Then again there is a confusion. Clear? So we'll understand that why I can use the variables in different, like why I am using the same name or same variable name in different functions. What is the why they are not colliding each other? That we'll also discuss in our future classes. Okay, get it?
Okay, sir.
So the basic part we understand that. Okay, we have already 11. Yeah, okay. So let me conclude the class for today. In our next class, we will discuss in the following scenarios. Okay.
Sir, is there no header file in C where we can include all header files?
No, not. We don't have the inclusion of all header files. We have different header files with different needs, because inclusion of all header files is basically a overhead for the compiler. Yeah. If we include all header files in a single, all the functions in a single header files, then this is basically overhead for the compiler. So they are basically organized in different header files. Okay.
Okay, sir.
Understand? Like think that you are in the market, so your all items are available in the same shop, including fish, glossary, etc. So this is overhead for the shopkeeper. So he cannot manage these things like that. Okay.
Okay, sir.
Okay. So in any other doubt?